Good morning, everyone. My name is Pooja, and I'll be presenting along with my teammates Nehala, Achana, Monikropina, and Harika about our work on blockchain technologies in check clearance and verification systems. So, to start with, traditional check clearance systems are often slow, manual, and prone to fraud. In fact, it usually takes 2 to 3 days for a check to be processed. So, this is where blockchain technology comes in. Blockchain provides a decentralized, immutable, and highly secure platform to record and verify check transactions. On top of that, smart contracts can automate check validation and fund transfers, which means no middlemen are required. This greatly reduces the overall processing time. We can also create digital checks that are tokenized and tracked on the blockchain, making the system tamper proof, transparent, and enabling real time clearance. Um, Frameworks can even integrate machine learning and federated learning to detect unusual activities and prevent fraudulent behavior in transactions. Overall, blockchain technologies and blockchain based systems have shown dramatic improvements in terms of speed, accuracy, and integrity, and also mainly in security, with check clearance times reduced with days from days to just under 2 seconds. Now, I'll be talking about the importance of applying blockchain in check clearance systems. The first and most important point is that blockchain helps eliminate delays and inefficiencies in the traditional check clearance process, which usually takes a couple of days. Second, smart contracts can automate check verification and settlement, making the entire process faster and more reliable. So it also enhances transaction security by using cryptographic signatures and hashing. Blockchain records are tamper-proof and immutable, so the history of every check is completely transparent and secure. Another major advantage is that dependency on centralized clearinghouses and third-party intermediaries are reduced. So this not only reduces the speed but also the cost. So fraud detection is also stronger as blockchain combined with machine learning can quickly identify suspicious activities. So by improving security and transparency, customer trust in the banking system also increases. With with that, I'll hand it over to my teammate Harika for related works.
Now I'll discuss the related work carried out in the area of blockchain-based check clearance systems. I'll briefly summarize the key contributions, their features, and the challenges they faced. First paper, which is written by Tejaswi. They built a hybrid system combining Ethereum smart contracts with a Zambo backend and linked checks using QR codes. This system automates check verification and ensures transparency. But the major issues are high Ethereum gas fees and difficulty integrating with existing ones. The second paper, which is written by B.K. Sharma, this is more of a conceptual model. It explains how check processing can be decentralized using smart contracts and digital assets. The strength is in covering fundamentals like proof of work and Merkle trees, but the limitation is that it remains theoretical, not practical. In the third paper, which is written by Kirtana and Ambikapati, they propose the checkmate system, which combines blockchain with fraud detection. It supports OTP verification and even mobile check scanning. It can clear checks in under 5 minutes, but again faces the problem of Ethereum's high transaction costs and practical adoption challenges. In the fourth paper, which is written by Sayed, their system uses a hybrid check deposit model with incentives for miners. It enables real-time settlement, ensures tamper-proof transactions, and supports miners through income mechanisms. The challenge is that it requires specialized infrastructure and strong integration with banks. Fifth paper, which is written by Kusuma and Ramya, they focused on smart contracts for verification and fund transfer, with cryptographic signatures for tamper-proof processing. It ensures real-time settlement and eliminates intermediaries, but has challenges in complex implementation and handling damaged or multi-format checks. The last paper, which is written by Suresh, Their approach integrates blockchain with IoT and AI techniques for check verification. It uses fraud detection through behavioral analysis and introduces a federated learning model called Block Handler. While very advanced, it needs heavy resources and complex infrastructure. And with that, I'll hand it over to my teammate Monique. She'll explain summary gaps and problem statement.
These are some of gaps we identified in literature study. Static signature verification. It only compares stored images, which ignores speed, pressure, stroke order, which is vulnerable to skill forgeries. Next is fraud and tampering risk. Centralized databases can be altered, no tamper-proof storage. Weak check image validation, which uses only basic pixel or template matching, fails against high-quality scanned images. Missing multi-entity consensus. Verification done by a single party, risk of insider fraud and single points of failure. Moving on to the problem statement. Our goal is to develop a blockchain-based dynamic signature verification system for secure check authentication. Current systems rely on static signature matching and centralized databases, which makes them vulnerable to forgery, tampering, and insider attacks. These traditional methods also use basic image validation, so they cannot reliably detect high-quality counterfeits. Moreover, the lack of multi-entry consensus means that the trust in the verification process is low, since a single authority handles all approvals. By using dynamic signature features and blockchain technology, our system aims to enhance security, prevent fraud, and improve trust in check verification. Objectives. Our main objective is to design a check signature verification system that uses dynamic behavior features like stroke order, writing speed, and pressure. We want to overcome the weakness of static image-based methods, which often fail to detect skill forgeries. To achieve this, we will collect stylus and touch input data from the devices such as tablets, and then apply machine learning algorithms to accurately classify genuine versus forged signatures. At the same time, we aim to ensure the system is accurate, reliable, and user-friendly for the users. Finally, we'll integrate the system with a blockchain-based check clearance platform, making it tamper-proof and supported by multi-entity consensus for higher trust. Now, Ashna will continue the next topic, existing methodology.
This is a flowchart for an existing methodology. This flowchart describes an automated system for verifying a check using its signature. The process will begin when a user uploads a scanned image of a check. The system then focuses on the signature region. It processes this area by converting it to a grayscale and binarizing it, that is, making it into black and white, and then creating a skeletonized version, that is, a thin line representation of the signature. This simplified signature is then compared with a stored pre-verified signature template to check for a match. If the signature matches, then the process will continue, and if the signature does not match, the system will reject the check. And when the process continues, the system will trigger a smart OCR, that is optical character recognition, to extract key data from the check, such as the check number, and stores this information along with the verification status. Next, it will generate a QR code containing the check status and other details. Finally, this QR code is embedded onto a verified digital version of the check. The bank and the user are then notified with this verified digital check and a new QR code. This completes the automated verification process. Now, this is the proposed methodology diagram, and this flowchart outlines a system for dynamic signature verification for a digital check. It's different from verifying a scanned image because this will analyze how the signature is created and not just how it looks. First, the user signs the check using a stylus or touchscreen in a mobile app. The system captures the dynamic data from this process, including the stroke speed, pen direction, and how the pen pressure changes. This raw data is then pre-processed to remove the noise and normalize it. Next, the system will extract features from the normalized data. It looks at things like the timing and flow of the signature, as well as geometric features to create a detailed profile of the user signing style. The profile is then fed into an ML model like SVM, that is a support vector machine for verification. This model compares the newly signed signature with the user's predefined unstored signature. If a match is found, the system will create a smart contract and signature hash. The check data and the signature hash are then stored on the blockchain, creating a tamper-proof and transparent record. If there is no match, the signature will not be verified, and there'll be a suspicious and alert notification sent to both the bank and the user. Finally, the process is complete and the bank and user are notified of the check status, whether it is cleared or rejected. Now, Mahela will be explaining about the technologies to be used. So these are the technologies we have used in our project. The first technology is dynamic signature verification. So it is a biometric method to verify the authenticity of a signature based on how it is written rather than how it looks. Here it captures the input from the stylus or touchscreen using the speed, pressure, stroke, and order. It extracts the behavioral features unique to the signer and is used to distinguish between the genuine and forged signatures. The second technology to be used is the database and security. Here we use it is used to store the users and check data securely, and the technologies used are the PostgreSQL and MongoDB, which is used for storing the users and check information in a structured or flexible format. And the SHA-256 hashing converts the signature into an irreversible hash value for tamper-proof storage. The third technology to be used is blockchain technology. Here, the smart contracts in Solidity, a self-executing program that runs on Ethereum, that is used for automating the check verification and clearance without the human intervention. And we use the Ganache and Truffle suite for development and testing. The last technology to be used is machine learning. Here it classifies the signature whether it is genuine or forged. And the technology we used are the algorithms are the SVM, support vector machine. Libraries are NumPy, Pandas, and scikit-learn. Hardware requirements. On the other side, we need the touch-enabled devices like tablets or smartphones to capture the user's dynamic signature, which includes the speed, pressure, and direction. A high-performance server is required to run the blockchain node. The host the machine learning model and can handle the APIs. We also need a stable internet connection for a real-time verification and blockchain synchronization, along with the secure storage, either the cloud or an on-premise for check data signature logs, and the blockchain records. Software requirements. On the software side, we use the Ganache as a blockchain platform to deploy and test the smart contracts. The programming is done using the Solidity for smart contracts, Python for machine learning models, and JavaScript with HTML for the web interface. For data storage, we rely on the PostgreSQL or MongoDB to handle the check and user data. Finally, for signature verification, we use the machine learning framework like scikit-learn. Now, the status part will be handled by Pooja.
So now I'm going to talk about the status of check clearance systems in national level. So in India, the banking sector still depends a lot on traditional check clearing systems. These processes usually take 2 to 3 days since they rely on centralized clearing houses. Although the RBI has introduced CTS, the check truncation system, to improve efficiency, challenges remain. For example, frauds like forged signature or tampered checks continue to occur. At the same time, research on blockchain technology in India is growing. However, when it comes to applying blockchain specifically for clearance, check clearance, it is still at a very early stage. The second one is international status. If we look globally, countries like the USA, UK, and Singapore are already experimenting with blockchain-based financial systems to enable faster settlements. European banks, for example, are integrating our blockchain for cross-border payments, which helps in reducing fraud and delays. Thank you.
The conclusion. So our project develops a blockchain-based check verification system that uses the dynamic signature verification with the machine learning to detect the forgery. The check transactions are recorded on the blockchain via a smart contract, and a web dashboard provides the real-time status updates, ensuring the security, transparency, and efficiency in banking.